Okay, good night. Your student Professor Dr. Dolphy Gilpin, and we're continuing with our introduction to the series elements of the periodic table, and we're in the lanthionide series, but we're doing a sort of random thing, random selection, and we're here with we did 70. Now, 71 Lutetium, yeah, Lutetium. Lutetium. Okay, so here we have lithium, atomic number 71, and atomic weight of 174.117, which would be like the most popular, the most stable isotope of lithium. Alright, we did offline. I did all the work in separating it from our decks, so that we would use up the time here just to separate it from our deck. So we're going to have these here. You'll see on here. And we say now, atomic number 71, atomic weight 174.9668, electronic configuration 4f14, that is Xeon XC 4x14 5d 6x2. It's a solid at room temperature. Lithium is used in research most of the time. Most used in research. Its compounds are used as O's for scintillators and X-ray phosphors, and the oxide is used in optical lenses, and the element behave as a typical rare earth metal. So you could expect certain reactions like they being flammable when you divide up the powders and things like that, and reacting with allergens and so on. But we'll come on to that. They will behave as typical rare earth elements. Now, they will form a series of compounds in oxidation state of +3, such as lithium sesquioxide, sulfate, and chloride. Lithium is more abundant in the earth than gold, silver, platinum, metal. So it's more abundant than gold, silver, and platinum. And lithium and its compounds are very expensive. Lithium is mildly toxic when ingested, but the salts are non-toxic. Now, gold is easier to obtain and is less costly. So gold is easier to obtain than lithium and is less costly to obtain than lithium. And this is another way of saying lithium is more expensive than gold, or more costly than gold. Gold costs at about 39.80 dollars per gram. And lithium costs about $340 per gram. So that lithium is more costly. Whereas gold is more easier to obtain. It's easier to obtain and less costly. So gold costs about $39.80 per gram, and lithium $240 per gram. Now, Lutetium 177, which is a Vipiprotide and Extern PSMA therapy. What's that? Prostate specific antigen. Something about prostate specific antigen here. In it's used, lithium is used 177, that isotope in PSMA therapy for prostate gland. And it's a new theranostic medicine for advanced metastatic prostate cancer. So that's its application to treat prostate cancer. And it's a new thing. And that's attributed to the Lutetium 177 isotope. So the PSMA is prostate-specific membrane antigen. And it's a type of reduction that specify a target, targets a molecule on the surface of a prostate cancer cell. So in this PSMA, or the prostate specific membrane antigen, the therapy, they target some molecule on the surface of a prostate cancer cell. Now, other use of lithium would be to manufacture memory devices, especially for gadolinium, gallium. Which is garnet as a dopant. 2, it is used as a catalyst in the petroleum industry. And 3, this metal is widely used in the process of hydrogenation, polymerization, and alkylation. And this Lutetium 176, so we have Lutetium 177, and then we have the isotope Lutetium 176, which decays into hafnium 176. So that is to be noted. Lutetium 176 decays into hafnium 176, and we'll be doing hafnium later on. It does that in the lithium-hafnium decay system. So we look at isotope 177, which is using the PSMA therapy, the prostate specific membrane antigen therapy. And then we look at the Lutetium 176 isotope, which decays into hafnium 176 in the lithium-hafnium decay system. All right, and let's take a short break here, and then we'll turn with lithium and then we'll try to get to hafnium.